Hello everyone, it's me, back with another video. I know, another video, crazy. I am in a physics class, if you did not know that. This is actually a physics project that I'm going to send to my teacher. Hello, teacher and other teacher of physics that I won't say the names of right now. This is my project. We're going to get into it now. So yeah, I guess just enjoy the show. People that are not in my physics class, I guess. I have my notes on here on a Google Doc because I'm cool like that, right? You can see, got our pieces of paper here. The project that I have been doing is, everybody does space, and that's cool. I like space, so I want to do space too. So I'm going to do, I did, kind of badly, the dying phases of a star, right? Because, stars, they die. And this is a star about our size. Because, a star bigger than our sun would go supernova and become like a black hole and all that. I didn't do that one. I did, basically, if our sun died, this is what would happen over a very long time. So the first one, obviously, right? Let me just chop it off right there. If I can do that effectively. Is the sun. Wow. Look at that. Wow. It's obviously not the best made, but it is what it is. Our sun is about 4.5 billion years old. That's an old man. Old man right there, right? It's made of helium and hydrogen gas, and it fuses them together in order to keep itself, running, and that's pretty sick. Its gravity keeps us all here and alive. I like being here and alive personally, so I'm saying that's a good thing. But this one eventually, it's like, oh boy, and then oh my gosh, and then it dies, right? And then you got the next one. If I can get that one down, this is gonna be fun. You got, instead of the sun, it becomes a red giant. As you can see, it is a lot bigger because red giants are bigger. This is because they have stopped fusing helium and hydrogen together, meaning that they have to expand to keep all of their stuff. If our sun expanded, it would be just over our orbital ring. Therefore, like say this is Earth, it goes around in this circle, the sun would be right out there. So we would all be dead by this point already, obviously. Most of the bright stars you see out there in the sky, I don't see any of them because artificial lighting, but most of the things you see out there, those are red giants because they are bright and very common. But obviously that one eventually also dies when it runs out of helium. Oh no. And then it becomes a planetary nebula. How cool. I really like this one. I based this on a specific image. I don't know how well you can see any of these images. I don't know if I'm going to give close-ups, but it's got little green stuff right there. And then there's the purple core. And then there's this red haze all around it. And that's what used to be that, because when, the star runs out of helium. When the star runs out of helium, it can't hold its shape anymore, so it just becomes this weird cloud of gas and plasma. It's pretty sick. You can't see these from Earth because they're very dim compared to the bright red giants because it's all spread out now. So you can't see any of them, but we have satellite images of them and things. But eventually, of course, this next one isn't really like a progression of them. It's just, that purple thing in the middle. It wasn't actually purple. That is what we call a white dwarf, which is the next one. I don't actually know how well you can hear me when I turn around like this. I probably should have tested that. There's the white dwarf. It's really tiny, and I don't know if you can see it. I'm going to walk over to this side now. There's a pole there. I'm over here now. Okay. White dwarf, right? Is very small. Because this is the original core of the star. You know, that big old massive star? That's its core, right there. It's only slightly bigger than Earth is. At least ours is, I think, yes. We're gonna go with that. That is what is at the center of the Planetary Nebula, and it is constantly, since it doesn't have any like fuel really anymore, its gravity is constantly pushing it in, right? To the point where even the electrons themselves, they are closer to the main atom because they are being crushed in by the gravity, and it's also getting colder. Um, that that sucks too. Um, this is the last one that has actually happened for any star. There is, oh my gosh, if I can. There is, however, a theoretical fifth part, right? And that, I'm going to throw my phone away because I already know this one. This one is called a black dwarf, right? Where the heck? So like I said, black dwarfs are only theoretical, because it takes so long to form these that the universe is not old enough that any of these could form. This happens when a white dwarf gets too cold and turns completely black because it has lost all ability to cast light. That's kind of all we know about it, considering it doesn't actually exist right now. So, yeah, that's the phases of a dead star. So, if you see the sun getting bigger, run, because it will become large, and then will kill you. If I could do this again, I would probably just like take more time on it and make those look better, because those don't really look that good. But you know, I don't have really an artistic talent or a talent for much else. I should. Okay. Anyways, that will be all for today. If you enjoyed this video, watch more of them. Unless you are my physics teacher, I mean, you technically could, but I don't really know why you would. But yeah, I will see every one of you later. Bye bye.